Hello guys, welcome to Science 6.2b. So we are still talking about the types of heat transfer. We're done with expansion. I hope that you understood that at least a little bit to get the base of it all. That when substances are exposed to heat, they expand according to their sensitivity basically of the material that they have. So, we learned that copper is more sensitive to heat, to expansion, than steel is, which helps thermostats work. We know that concrete and steel can expand at basically the same rate, which makes bridges work the way that they do, okay? And that expansion of water is completely different than anything else, but it's the way that God designed it so that, ice doesn't take over the world basically. And that the nature can still have the process and work the way that it does without anyone intervening, right? Okay, so very, very interesting for heat expansion. Then we started talking about heat transfer, where the only one that we got into yesterday was conduction, which means conduction is where there's direct transfer of heat, that something touches something that's already hot, and that thermal energy is transferred over, creating that heat. And it just depends on the material. If it is a good conductor of heat, it's going to heat up quickly. If it's a slow conductor of heat, then the thing on the other end, whether or not it's your hand or something else, won't be affected from it rapidly or immediately, okay? Because the heat will take time to travel through something that's not a good conductor of heat. Today you're going to learn that air is not a very good conductor of heat, okay? And so that is going to help us understand convection currents, going to help us understand convection heating, going to help us understand why certain water bottles and can insulate things to make them stay hot for a very long time or cold for a very long time if you create a vacuum where there's even less conduction of heat. Okay, so that's what you're going to get into today. Yesterday with conduction, we learned about the miner's safety lamp, which I hope you enjoyed the video, which was interesting how the screen could literally stop the fire from going outside the lamp, even though it was mixed with the chemical outside in the air. Okay, so that's what Sir Humphrey Davy found out just by studying simple scientific principles, you guys. Simple scientific principles, conduction of heat, different materials, and he was able to apply that to affect many people and save many lives, okay, because he didn't give up on that invention and other inventions that he did, right? So go over to page 136. I know it's my famous last words to say that this video is not going to be very long, but I'm thinking that this video is not going to be very long, okay? We're going to be talking about two major things today, which is convection and radiation. So let me give you the topics that you're going to talk about today, and really it's going to be up to you. There's not a lot to explain here because I think the way that I'm going to give you the topics is really going to guide you to understand these last two types of heat transfer. And the book does a very good job giving many examples how these types of transfers apply to the real world, and you can see them every day and imagine how they work, okay? So the very first one is convection. So here's what you need to do for convection. You need to give me 3 sentences on how convection works. You're gonna find that on just this very first paragraph right here, okay? Make sure that it's in your own words. You don't want to just copy 3 sentences out of that paragraph, obviously, okay? Convection is all about currents, you guys. Heat rises, cool air falls. That's going to create currents in the air, okay? That's going to create wind currents. That's going to create currents in the ocean, okay? And that's all the stuff those are some of the things that you're going to learn about today about convection current winds, okay, and how it affects the entire earth and how it works. But it's also applied to heating up a room. It's also applied to heating up a greenhouse. It's also applied to heating up the earth with the tectonic plates. Convection currents are everywhere, you guys, okay? So The basic principle though is heat rises, hot air rises, cool air falls, creating a cycle, okay? Creating a cycle. Because let's say that you have a source of heat, a fire, a radiator, a furnace. You have a source of heat that's heating up the air around it, okay? Well, obviously, that source of heat has air heated up around it, so what's gonna happen to that air? It's gonna go up into the ceiling, the atmosphere, whatever it is. But then, eventually, that air is gonna cool down, and it's gonna come back, okay? You're gonna look at all the life applications to that today, so I'm not gonna go into it more. But 3 sentences on convection, then I want you to tell me in 3 sentences how convection currents apply to heating up a room. To heating up a room. Then 3 sentences on how convection currents apply to wind, which you're gonna find in this one right here. You're gonna understand, we talked about this before, but very briefly, you're gonna understand why during the day the wind is coming from the sea, and then during the night the wind is coming from the land to the sea, okay? There's some really windy days and some really windy nights that you can pay attention to where this wind is coming from, especially if you live close to the water like we do right here, during the day and during the night, and that's applied here. So 3 sentences about that. Then if you look on page 137, 3 sentences about how this affects tectonic plates, because tectonic plates, you guys, affect earthquakes. Okay, so how does it affect tectonic plates? It seems small, but even small movement can cause a temblor. Okay, then we're gonna get into radiation. Okay, you're just gonna give me 5 sentences on how radiation works. 5 sentences on how radiation works. Then go to page 138. Radiation, you guys, by the way, is gonna tell you that dark clothes absorb heat, light clothes reflect heat. That's why on a hot day, if I'm standing in the sun and I have this black shirt on, but you have a white shirt on, who's gonna feel more heat? Me, okay? That's radiation in an application. Then you're gonna give me 4 sentences on how, look at page 138, how radiation and convection make a greenhouse work, okay? How radiation and convection make a greenhouse work. They also mention here when like babies are trapped inside a car. Guys, you know that happens so much in the United States, that a mom can get like super busy and she's doing mandados with her kids in the back seat, and she'll leave the car totally closed with her kids in the back seat, forgetting that they were with her, and going to the store for an hour. Little kids have died that way, and it's because of this greenhouse effect, okay? But it's really sad when that kind of stuff happens. Okay, then you're gonna give me 2 sentences on how the Dewar flask works, or the vacuum bottle. That's on page 138. That's interesting because now it's a trend. I don't have my water bottle with me this time. Now it's a trend to have those insulated bottles, right, that keep your water cold for 24 hours or keep your coffee hot for 16 hours or whatever it is. This principle comes from right here. So 2 sentences about that. 2 sentences about hot water heating systems, 2 sentences about forced warm air systems. And then I want you to do just a quick chart, table, however you want to design it, the similarities and differences between the 3 types of heat transfer. That's one from yesterday: conduction, convection, radiation. Similarities and differences between the 2. You should have at least 3 points for each. 3 similarities, 3 differences. Okay, it's just a comparison thing that we want to do there. Okay, and then make sure you do your section review 6.2. I'm also gonna attach a video to this that's like 2 minutes long I want you to give me 2 sentences on how convection currents also affect ocean currents. Just 2 sentences, okay? A lot of topics today, but now I'm getting out of your way. Go for it. Bye.
Take a deep breath. Get ready for one of the most hypnotic things you'll ever see in a science class. Have you heard that heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in 2 big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. Understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this for yourself, click on this link for all the directions you'll need. Thanks for watching.